Sorry, it's a few minutes late. Yeah, I'm going to talk about Cosmos 101 today. I want to do that in 20 minutes or less. We've got a little bit less than 20 minutes now, so I'm going to jump straight into it. But the idea of this talk is to kind of give you a kind of beginner's thing, right? So the kind of a beginner's from zero to Cosmos, to getting started in Cosmos, kind of the talk that I would want to give myself, say 5 years ago when I first kind of touched Cosmos. That's the idea of this talk, right? So you get kind of started on Cosmos DB, learn some kind of concepts, and just be able to go away and kind of get started. So hopefully that'll be helpful. That works. Cool. Just a quick thing about me. I'm going to jump through this really quickly just to catch up on time, but I'm a senior consultant at Avanade. I'm interested in Azure data platforms, right? And have a degree in computer science. I'm interested about a bunch of other things. Don't like Excel that much, but it's great to kind of meet you all and hopefully having a good day at SQL Bits. And there's one more session to go, so hopefully you guys can go to the next session. But what we're going to do today, so we're going to kind of go on a video game quest, right, to Cosmos. So we're going to go what Cosmos DB is. We're going to kind of jump through a couple of key concepts, and then we're going to talk about when you can kind of use it and do a quick demo, hopefully if we have enough time. And I think first part, right, so we want to talk about kind of what Cosmos DB is. So every hero needs a good origin story, right? And when we're kind of talking about video games. And what is Azure Cosmos DB? It's a fully managed NoSQL database that has planet scale. And that is, to be honest, a bunch of words, right? It's not going to tell you much, especially if you don't know much about NoSQL. So let's break it down a little bit. NoSQL, by definition, right, is the opposite of SQL or not SQL, as people kind of call it. It's non-relational, it's schemaless, it can kind of handle semi-structured, unstructured data of various different types. And it's not that kind of rigid row column structure that you get with SQL. So there's kind of good flexibility there. It's also managed, right? That's one of the other words there. Managed, obviously, is platform as a service offering, which is great. It means you don't have to do all that kind of infrastructure setup. You don't have to, build, planet scale stuff yourself, right? Either if that's inside of Azure with infrastructure as a service and having to spin up VMs, or if you have to do it, with physical infrastructure. All that stuff's given to you. Microsoft are very, very passionate about the SLAs behind Cosmos. We'll come on to that a little bit. But, they're very, very passionate. And it gives you a bunch of other features. You can distribute data workloads, obviously, around the world by having multiple data centers, but also you can kind of have enterprise security features. Cool. Oh, too far. And like I said, planet scale, so you can replicate your data around the world. You can distribute it around the world too. You can have different read-write regions, and you can, like I said, you can locate your data closer to your applications and users, which I think is really awesome, especially when you've got high throughput, high concurrency problems, right? So it's very, very helpful. And SLAs, like I said, Microsoft have mostly like 5 nines, we'll say, on SLAs behind Cosmos DB. Some are not, but most of them are. All your money back, and by money back, I mean Azure service credit. Microsoft don't give you free money, but they're very, very passionate about, they can deliver on this. And they have a tab on the monitor page of Cosmos DB where you can measure your Cosmos DB performance against the SLAs that they guarantee. They're that confident, right? They show you the data. And one of the benefits of Cosmos DB is that it's multimodal. So there's a bunch of different APIs you can use, right? You can do SQL, you can kind of do Mongo, and you can do Cassandra and graph databases with Gremlin. And my personal favorite, right, the unsung hero of all of Azure is Azure Table Storage. And they have a table storage API that gives you all those SLAs that you get with Cosmos DB on top of kind of the Azure Table Storage key value pair kind of data store. But yeah, ultimately, there's a bunch of useful different APIs there you can integrate with. Some of them are open source, and they give you a bunch of capabilities, right? So quick recap of what Cosmos is. It's NoSQL, it's distributed, it's got high throughput, right? It's highly scalable, and it has a bunch of different multimodal kind of modes that you can use to support different use cases, right? So if I need to model relationships with graphs, it's great. If I need to kind of capture JSON data to serve to APIs, that's also great, right? I can do all those kind of things with a Cosmos DB. And we can kind of jump into what are the key concepts, right, about Cosmos. So what attributes and skills does our hero have that's going to help us, save the world or kind of deliver value to our clients and organizations? So kind of 4 concepts I want to talk about. I really want to talk about 5, but I didn't have time before the few minutes were behind, and I definitely don't have time now to talk about it. So for the kind of four main components, we've got a database, a container, an item, and then request units. And I think request units are important because they cost you money, and that's ultimately the most important bit about Cosmos. So the kind of components, right? You have this database account, Cosmos database account. It's similar to a SQL Server kind of, instance. You can have multiple databases in that, and that database can contain multiple containers. Containers could be really considered tables in SQL, but they're not exactly the same because they can contain, a bunch of stuff without schema, so they're not, directly related data points or kind of data. A good analogy, the game world, right, is that a database account is like a franchise, like Mario. A database is like Mario Kart, one of the Mario games, right? And a container is like one of the levels. So Rainbow Road, should we say, in Mario Kart, that famous level, and all the different items inside that can kind of have different structures and different data points are all, say, the characters, the cars, right? They all kind of have similar attributes, say, between characters with different values, and similar sort of attributes for cars with different values. But ultimately, they're not the same structures, and same with those power-ups, right? You get in levels, they all have kind of similar like attributes. Well, they have different values, but they're not the same data structure fundamentally as things like a Mario Kart car. If that makes sense. So they kind of, you can collect things of related information, but without the same schema, right? You're not forced into the kind of rigid schema enforcement. And Microsoft have a nice diagram here that I'm going to not talk about, but you can get it on the documentation. It talks about what I just mentioned effectively. And partitioning, I'm going to quickly jump through partitioning because it could be a really complicated conversation all on its own. But ultimately, partitioning gives you some kind of, when you get SQL, you kind of have to, you sometimes get away with not thinking about partitioning, right, when you're working with SQL, but Cosmos kind of makes it the forefront, right? You need to make decisions ahead of time on your partitioning. And you need to choose it when you're creating a container, what kind of partition key you have. I'll give you an example from something kind of we've delivered. We chose like a hashing algorithm to build partitions, partition values based upon last names, right? And that's a really good way to distribute a bunch of data into a bunch of different partitions, right? The problem is there's like some really hot partitions in there, right, with really popular names, right? My name is Bell. That's quite a popular name in the UK. Smith is an incredibly popular name, right? And if you look at the analysis of that partition in Cosmos DB, that partition was particularly very hot because it's just a lot of Smiths and a lot of people potentially accessing that data. And kind of that thing I mentioned, request units, I think really important thing to cover. And request, effectively, they cover kind of the complexity, right? So they calculate the complexity of an operation, kind of a CPU, the IO, and the memory required to do a thing, like a read, write, query, right? They capture that. And they also obviously represent a cost, right? You provision either some IUs or you pay for the amount of IUs you use on demand, and those things cost you money. So ultimately, you need to pay a lot of attention to that, otherwise it can get away from you, especially with Cosmos. There's a diagram here again from Microsoft documentation. I'm not going to go through it. It's just in the PowerPoint for reference, and there's some links at the end, but it kind of talks about that in detail. And then something that I'm not going to talk about, but I originally really wanted to talk about in this talk, but I realized it'd probably take 20 minutes just on its own, is the consistency models in Cosmos. So I'll just briefly touch on it. You can, there's effectively, you don't get, in SQL, you get a bunch of nice things out the box, like ACID compliance. And in Cosmos, because it's distributed and because a bunch of the kind of the data it stores, you don't necessarily get the same sort of level of consistency potentially. There's kind of a varying of options. You can use them based upon your use case. They go from eventual, which by its very name, right, is eventually consistent, all the way to strong. And strong consistency effectively, right, is as rigid as you can get. And everyone thinks they need strong consistency, but often they fall on the spectrum somewhere between the two of eventual and strong. But you just need to kind of work through that. Personally, most solutions I kind of see look kind of around the session-based consistency model. But I think, just evaluate it. On the face of it, you always think you need strong consistency, but you unlikely do. And then there's some scaling, right? So just the kind of scaling, there's three kind of main models. There's serverless, right, which is all based around you consume IUs and you pay for what you consume, right, which is great for kind of irregular access patterns and low traffic applications. If you've got high peaks, consistent traffic, you're going to pay a lot of money and potentially degrade your performance by choosing that model. Provisioned is kind of I pay for a set capacity of a database or a container level inside my database, which is great. You can increase your throughput throughout that. But one of the things about that is you can kind of go, I've got a fixed cost, right? You can still scale up and scale down if you need to, but you've got a fixed cost. It's great. You can kind of just degrade performance of your application if you need to in order to not go over that cost. Or autopilot, which I say is kind of a newish feature, but really it's probably 2 years old now, which allows you kind of to auto scale Cosmos DB and, based upon kind of demand, right? Which is great. And again, it's a feature that it can leverage quite well in applications, but it also there's a potential cost overhead there, which is a useful thing to note. Also to note on scaling, per gigabyte, I think you have to pay for 10 IUs. So the storage capacity, even not the demand of how much your database is accessed, is really quite could be quite important, right? So you need to think about that if you're storing lots of data. There are some other options with Cosmos on Azure about that, but I don't want to cover that today. So just a quick recap, right? What's our hero's attributes, right? They've got really good SLAs, they've got good throughput and good capacity, got no schema, which actually for us is a benefit, right? They've got distributed compute around the world. It's multimodal, kind of some of the key skills. It's got flexible consistency models based upon what I need to do and deliver, and I've got planet scale. So that's a really, really helpful overview of our hero. Just keeping an eye on my time. And when to kind of use it, right? So when to use Cosmos DB. I'm gonna, because I'm conscious we're stuck for time, right? I'm just gonna very, very quickly run through this because I want to go into a demo. Effectively, we had a client use case that required a bunch of customer data from disparate transactional systems to be captured, and they had multiple attributes, right? Depending on what kind of system they came from, they were not potentially the same business area. By capturing them in like an unstructured kind of JSON with the Cosmos Core API, you can kind of extract the common attributes and allow for business specific attributes to still sit in those transactions and sit around around customer information. I think that's really quite powerful, right? Because you can leverage multiple applications off like a single version of the truth, which is kind of awesome. So I'm going to jump into, I'm conscious that we're a few minutes behind, so I'm going to jump into a build and I'm going to show you guys how to get started from like kind of zero to some Cosmos, right? Let's do some Cosmos. Hopefully you all can see my screen, right? So I've got a resource group in Azure. This is super quick how you create a Cosmos DB database. This is not important. I'm going to do this in less than like 30 seconds just to show you. Right, I'm going to search for Azure Cosmos DB. I'm going to create it right in Portal. It's like how you'd create any other service in Portal. Hopefully everyone already knows how to do this. I create it. I can choose the API that we just spoke about, which is Core SQL. And I can choose, where I want to deploy it and various bits around that. And I can choose all those things we talked about, like account name, something like that. And I can choose the different modes I want to choose. And there's all sorts of options up here around, networking, global distribution, encryption, like I kind of mentioned, for security-based reasons. You can have enterprise-grade customer managed keys, all that kind of stuff can come in there, which is great. But I don't want to talk about that, right? I want to talk about how we write some data. So I've got a Cosmos DB that I already own. I do own the namespace prod.documents.azure.net because no one else apparently owned it about a year ago. So I've made a database. You can do that via the UI pretty easily. And you can create a database, you create a container. Ultimately, when you do that, you get to choose, throughput and all those things we just spoke about. And I've been capturing Wordle data for some other projects I'm working on. And you can kind of see documents. This is what a JSON document in Cosmos DB looks like. And if you want to make a document to get started super quick, like the UI, you can just do that, clicking new item up here and just pasting some valid JSON in there, right? Only thing that's mandatory is an ID. To do that, I'll show you quickly. I'm just going to make a random ID up and save some repeated data in there. And I've captured some data in Cosmos. I can use that to query Cosmos. I'm going to use Databricks to query that. Other tools you can use any tool you want. I've been capturing Wordle data for every day of Wordle. So today's Wordle is this one. Hopefully you all know what Wordle is. This is going to be terrible. And I've been capturing, it's some JSON and then kind of the structure that comes back from the Twitter API about Wordle. I've been kind of capturing it, manipulating it. Well, again, it's not really important in the context of Cosmos, but I just work out what the score is based upon some really basic logic in Python, capture the ID of the tweet, and then I effectively want to write this data to Cosmos DB. So, I've got this data, I'm going to write it and capture it. I'm using the Cosmos connector in Databricks. Again, it's not that important. You can use Azure Functions, use anything, right, to write data to Cosmos. There's a ton of SDKs. But I've written some data. You can kind of see it in here. I've written the Twitter API data along with some derived score here. This person did great on Wordle, I think. I think that's what it means. And you can kind of leverage that. And again, I can query that data and have a look at some of that kind of Wordle data. Again, so the benefit, right, is here you can kind of get started. All this stuff's on GitHub. So if you've got Databricks, you can kind of go away and do it. And you can kind of go away and just follow this and hopefully get started on Cosmos and then start writing data to Cosmos and doing something interesting. You don't have to necessarily do Twitter or Wordle, but I think it's really good. And hopefully you guys enjoyed that. And I'm just gonna jump back to my slides really quick. I've got a bunch of links. The slides are obviously available online. And you can get, there's all sorts of stuff I couldn't talk about that I think really is important to talk about and you should read up on. And there's a bunch of useful stuff such as the Cosmos emulator to save you money to run locally and cost profiling and how you can choose like a appropriate scale model for Cosmos DB. And yeah, thank you. So please do feedback on the session. I want to know what to do better for next time. Kind of for 101 sessions, and I also want to plant some trees, which SQL Bits are doing, so it'd be great to do that. And if you guys have any questions, obviously the session's about to run out of time, but you can email me, you can tweet me, and if you've got any kind of start on a Cosmos journey, please do tweet me. I'd be really interested to see. Thank you. Hopefully you found that useful. If there's any questions, I will answer them in the chat.